any confusion after the last class? Any question? Hello.
Sir, I was absent, sir. I will go through the video, sir, recording.
Okay. What about others? Okay, so for others, I hope that's clear. No, so there's a Rishikesh, Emil. Emil has been, yes, Emil, you're writing. I am absent yesterday, but you have been absent in so many classes now. So have you gone through the videos and all that I have been uploading, Emil? Okay. So I hope this screen is visible. The PPT is visible. Let me know.
Yes, sir.
Okay. So yesterday we are talking about like discussing about the different gear trends. Okay. So there we have seen like four basic categories that we are going to discuss in details is the simple gear train, the compound gear train, reverted gear train, and planetary or epicyclic gear train. Out of these four, so simple as well as compound gear train, already we have seen like some initial discussion we had, but today we are going to go in detail. So now this simple gear train, how we can say? Okay, so here here it's a kind of series of gears, okay, which are in proper mesh, and they are capable of receiving as well as transmitting motion from one gear to another, okay, and that particular series of gear which is in proper mesh is known as simple gear train. So yesterday already we have discussed to use the word gear train, we have a minimum of three gears which should be in mesh, okay, so that is the minimum thing. Otherwise, we don't. If only two gears which are in mesh and transmitting motion from one shaft to another, then we don't use the word gear train. Okay, to use the word gear train judiciously, a minimum of three gears would be there. So it also it may be more than that. Okay, so now how to distinguish this simple gear train from the other type of gear train? So now in that particular case, what happens? So here all the gear axes are fixed. Okay, they remain fixed relative to the frame, and the main thing is that each carries on a separate shaft. That means one single shaft carries a single gear. So here in this particular figure, if you see, so here it's a kind of simple gear train that has been shown, but it is in zigzag fashion. Okay, so in the previous case, whatever we have seen, that was in the linear fashion. Like suppose this, okay, suppose one gear which is mounted on a single shaft. Then suppose let's consider another gear, okay, on another shaft. Let's consider we have got other gear which is in mesh. Okay, so in that case they are in linear fashion. Okay, but here if you look in this case, this is a kind of zigzag fashion. Okay, so that means both are possible. Okay, both the ways are possible, but the thing is here the gear axis remain fixed relative to the frame, and each gear is on a separate shaft. That is how you are going to distinguish it. Okay, so just like in the case of normal external gear meshing, so here also two external gears of a particular pair will always move in opposite direction. That means what? If you look at this particular zigzag fashion gear train, okay, simple gear train. So here you can say suppose gear 1, suppose this is gear 2, gear number 3, 4, and 5. Okay, now they are all in mesh. Okay, and this is what type of meshing? This is external meshing, as you can very easily see from the diagram. So now if gear 1 is rotating in this particular direction, anti-clockwise direction, with suppose angular velocity omega 1, then due to this particular thing, what will happen? gear 2 will rotate in this particular direction, okay, having certain angular velocity omega 2 depending on suppose what is the relationship between these two, okay, in terms of suppose size or number of teeth, etc., etc. Okay, now if you now consider gear 2 and gear 3, once again they are on two separate shafts, okay, and gear 2 is now rotating in the clockwise direction. Now, if you just consider this pair 2 and 3, then as if you can consider gear 2 becomes the driver and gear 3 becomes the driven. Now, in this particular case, from the gear 2, the motion will be transferred to gear 3, and due to this particular external meshing only, once again it will be rotated in the opposite direction to that of the directional movement of gear 2. Okay, so that means clockwise rotation will become anti-clockwise rotational movement of gear 3. Now, if you now consider gear 3 and 4, then the same thing. Which one is driver, which one is driven for the pair gear 3 and 4? For the gear pair, okay, 3 and 4. This one 3, this is 4. Which one is driver, which one is driven? Can you tell me? For this pair, which one becomes driver, which one becomes driven? Which one is having the initial velocity, initial motion? 3 or 4? Which is getting
Sir,
the motion
3, I
from?
think, sir. 3 is the driver.
Yeah. So,
Three.
okay, 3 is the driver and 4 becomes driven and so on. Okay, so like that. Okay, so now if you analyze properly, then basically what happens? So this 1, 3, 5, etc. Okay, all those odd numbers here is going to move in the same direction, and all those even numbered here, supposed to 4, okay, they are going to move in the opposite direction. Okay, that means 1, 3, 5 will have the same directional motion. Okay, suppose in the anti-clockwise direction, then 3 also in anti-clockwise direction, 5 also in anti-clockwise direction. Similarly, 2 and 4 will have same directional motion but opposite to the odd numbers. Okay, that is clockwise, clockwise. Okay, so as I have previously mentioned, these gears can be in a straight line, just like the previous diagram I have drawn, or maybe in a zigzag fashion like this. Okay, so now from the figures, okay, as we have previously seen, so we can very easily understand that. So initially, this is the kind of driver or kind of input. Okay, for that, for this pair 1 and 2, this is kind of the driven. Okay, and this is driven. This is driver. Okay, similarly for all the pairs you can consider, you can find out suppose which one becomes, suppose for this case driver, which one becomes driven. So now just to do the analysis, so from figure what we can write, so n2 by considering the first pair, okay, we can write the n2 by n1 equal to t1 by t2. If you just consider the first two gears which are in mesh from this particular simple gear train, okay, then we can write n2 by n1, okay, so it is inversely proportional to the number of teeth, okay, so it is why t1 by t2, right? So that we can write. Similarly for the other three other pairs, like if I now consider 2 and 3, next if I consider 3 and 4, next, if we consider 4 and 5 like that, then we can have similar kind of relationship valid for them. Okay, so we can write, so for other two similarly, like n3 by n2 will become t2 by t1. Similarly, n4 by n1 equal to t3 by t1, and n5 by n4 equal to t4 by t5, and so on. If we keep on increasing, suppose the number of gears in that gear train, then the other gears will follow. Okay, so now from there, so from after getting this relationship, okay, just by multiplying what we can get, so this left hand sides are being multiplied, okay, multiplied together equal to the product of the right hand side. Okay, so that means just multiplying all those n values equal to multiplication of this. Okay, so from here what I have seen, like n2 by n1 equal to n2, n3 by n2 like that. Okay, so this n2 and 2 get cancelled, and 3 get cancelled, and 4 and 4 get cancelled. What is remaining? And 5 by n1, which is nothing but the train value, equal to how much? T2 T2 get cancelled, T3 T3 get cancelled, T4 T4 get cancelled, equal to T1 by T5. That means what we have seen. So train value n5 by n1 equal to T1 by T5. That is the number of teeth. T1 means number of teeth on the driving gear. T5 is number of teeth on the driven gear. Okay. So finally, this is the like driver kind of the input. Okay. And final output we are getting here. That is the kind of the driven. Okay. So now we can write the speed ratio to be just a reverse of train value. That means n1 by n5 equal to t5 by t1. We can write like this. Okay. So now from here, what we basically we have seen. So that means in this speed ratio, do we have any role of the intermediate gears 2, 3, 4? Are they playing any role? Basically, they are not playing any role. So directly you have seen the speed ratio n1 by n5 equal to. It only depends on the number of teeth in the fast and the that is the driver and the driven gear. Okay. So we have seen that intermediate gears they basically do have no effect on the speed ratio, and that's why they are known as idler or idle gear. Okay, their purpose is like for they are transmitting motion from one sub to another, and in the meantime they are suppose from this position to that position. Okay, directly we are not transferring motion. Okay, intermediate gears we have, and they are playing the role of one is like facilitating this particular central distance. Okay, connection between this particular central distance. Apart from that, they are facilitating in the directional sense movement. Okay, so this one is direct moving in this. Okay, depending on how many numbers of idler gears are in between, so based on that the output in the output gear, okay, the direction can be obtained. That means if we have gear 6 as the final output gear, okay, where we want to output, then this from 2 to 4, 2 to 5, everything will become idler in that case. Okay, and the final gear will be this one, gear number 6. Okay, and it will be the relationship will be in between gear 1 and gear 5. But the thing is gear 5 gear 6, okay, gear 5 becoming idler in that particular case will once again change the directional movement of the output. Okay, so this is about your simple gearing. Understood? Let me know. I think we are back online, so all of you can hear me now.
Yes, sir.
Okay, so I think up to a simple gear train we have covered. Huh?
These are simple battery.
Yeah. Now we'll be discussing about the compound gear train. Okay. So what is compound gear train? So yeah, previously also we have discussed. So when a series of gears are connected in such a way that two or more gears rotate about an axis. Okay, two or more gears with the same angular velocity, then it is nothing but the compound gear train. That means in the previous case, in a single shaft we had only one gear. Now in some of the shafts here it is possible to have two or more more number of gears. But the thing is, they'll have the same angular velocity. Why? Because they are mounted on the same shaft. Okay, two or four gears, and depending on whatever be the shaft velocity, both the gears are keyed to that particular shaft only. That's why they will be getting the same angular velocity. Okay, so in the case, generally some of the intermediate subs they generally carry more than one gear, and in normal case, one of which acts as a follower and the other acts as a driver for a different sub. Okay, so suppose let's consider this particular figure. Okay, now you can see this is one sub position, another sub position, another sub, another sub. That is four sub. And now on the first sub, we are mounting a gear. Suppose gear number one. Now, as you can see from this particular figure, on the second shaft, okay, this shaft, in this particular position, we have mounted two gears on the same shaft, okay, gear 2 and gear 3, okay. So in the next one, if you look closely, this particular position, this and this second sub position and third sub position. So in the third shaft also we have mounted two gears, that is gear 4 and gear 5, and one of the gear. Okay, if you look here, this is this portion of this gear. Okay, is in math. These two gears, okay, 4 and 5, okay, they will also be having the same angular velocity. Now what is the beauty you see? Okay, now in this particular case what will happen, let's consider 1 and 2, okay, they are in mesh, right? 1 and 2. So now depending on this particular whatever will be the relationship between them, the relationship, dimension, relationship, etc. Okay, one is rotating in the anti-clockwise direction with angular velocity omega 1. So 2 also will be 2 will be rotating in the clockwise direction with angular velocity omega 2. Okay, because 1 and 2 are in mesh. Now where this gear 2 is mounted, it is mounted on this particular shaft, and on the same shaft gear 3 also is mounted, right? So now whatever is the angular velocity of gear 2, that is omega 2, it will be the same for gear 3 also. Okay, omega 2. Okay, but the thing is, here the size of gear 2 and gear 3, they are different. The number of teeth that is there on the gear 2 and gear 3, that is different. And now this gear 3, okay, having suppose angular velocity omega 2, which we have previously obtained, but having different teeth. Okay, now it is in mesh with gear 4 from this particular sub. Okay, now depending on whatever be the relationship between them, okay, so this gear 3 becomes the driver, okay, for the gear 4, and gear 4 will get certain angular velocities. Let's consider omega 4 it has obtained. Okay, so now gear 4 is mounted on the this sub. Okay, similarly the same another gear, that is gear 5, also is mounted on this same shaft only. So now because of the movement of the gear 4, whatever is the rotational motion that this particular shaft has obtained, so same motion will be delivered to gear 5 also. And now this gear 5 will in once again in term in motion like message this. Okay, so we can get different velocity ratio. Okay, that means what we can do, we can have multiple velocity ratios. Okay, more combination of velocity ratios by this compound gear train. Okay, understood. So here we are showing different views for the same case. So this is the situation that has been shown here. Okay, and if you look at, okay, then basically in another view, that means this is sub position. Let's consider we have got one gear here. Okay, now this is in mesh with this, that means this gear is in mesh with this. Okay, so this is in another sub, this is the sub position. Now on this same shaft we have got this gear 3 also, okay, which is smaller. This is this gear. Okay, now whatever motion this gear gets, okay, this will be the same motion, same direction. Okay, same value, direction, and same. Now this gear 3 is in mesh with this. Okay, now you see this is in mesh with this, not this. This gear is not in mesh with another gear, but rather this gear is in mesh. Okay, which is on sub this sub. Okay, and in the at last we can see this gear and this gear in mesh. Okay, which is another sub. So here this is the input sub, and final output is here. Okay, so similarly another view for this case you can see here. Okay, so on this sub single case, but in this sub 2 we have got multiple gears. This is one gear, this is another gear. Okay, now this gear is in mesh with this. Okay, on this sub also we have got multiple gears, gear 4 and gear 5, and final output is in this particular sub. Okay, understood. This is how this is the compound gear. Okay, now for velocity ratio or train value analysis, if you consider the gear 1 to be the driver gear, okay, this is the driver gear we are considering. Okay, now what we can write, n2 by n1 equal to t1 by T2. Okay, for this pair. Okay, next next pair which is in mass is this 3 and 4. Okay, 3 and 4 are now in mass. Okay, now 3 becomes driver, 4 becomes driven. Okay, so we can write n4 by n3 equal to t3 by t4. Similarly, sorry, now 5 from 4, the 5 gear number 5 has also got the motion. Now 5 is in mass with 6. Okay, so 5 is driver, 6 is driven. Okay, we can write n6 by n5 equal to t5 by t6. Now multiplying them just like in the previous case, what we have obtained, multiplying and simplifying. Okay, so n6 by n1 equal to T1 into T3 into T5 divided by T2 into T4 into T6. That means now we have seen all the intermediate gears have some role to play. So now what is the train value? So train value in this particular case is this 1, 3, 5. What are they? So they are the driving gears. If you look at here, okay, one is the one is driver. Next 3 is driver for 4. Similarly 5 is driver for 6. Okay, so it is the product of the number of teeth on the driving gears divided by the product of the number of teeth in the driven gears. Okay, that is the compound gear. Understood? Let me know. Hello, am I audible or not? People are there?
Audible, sir.
Yes, sir.
Yes, sir.
Okay. So the next type of keratin that we are going to discuss is reverted keratin. Okay, so here the how when we will know that suppose this particular keratin is a reverted keratin. So in this particular case, here the axis of the first and the last gear wheel they coincide. Okay, first and the last. In that case, we call it as a reverted keratin. Now, if you look at this particular figure, so let's consider this is one shaft. Okay, this is the shaft position for first shaft, and this is the gear that is mounted here, gear number 1. Okay, now let's consider gear 2 is mounted here. Okay, on second shaft. Now on this shaft itself we have got another gear 3. Okay, which is going to give motion to the last gear, that is gear 4, which is mounted here on this particular shaft. Okay, now if you look, if you extend, then this is the first gear, this is the last gear, that is kind of the input. Okay, this is kind of the output. Okay, now in that particular case, if you look closely, then the first and the last gear wheel, the axis they coincide, and if this be the situation, then generally we call this as reverted gear train. And now if it has to be reverted gear train, then some geometrical relationship must hold good. If you look closely, so for this pair and for this pair 3 and 4, now this distance remains same, right? This distance is same. Okay, and now how to get this distance is nothing but this from the radius from this wheel 1 plus the radius from gear 2. Now similarly for this combination, this is the radius value for gear 3 plus the radius of pitch circle radius of gear 4. Okay, so that is the relationship. Okay, so that is what we are writing, r1 plus r2 equal to r3 plus r4, because this distance are same. Or you can also write in terms of number of teeth, t1 plus t2 equal to 3 plus t4, where r1 t1 all those things are the r r is the nothing but the pitch circle radius. Okay, and this t is denoting the number of teeth, and the suffix 1 2 3 4 they are for the particular gear. Okay, so similarly where you can see this gear reverted kind of gear here. Okay, so in the you can see this reverted gear train in the back gear of a lathe. Similarly in different automotive transmission system, clock, etc. Okay, so this is how this reverted gear train. Okay, next last one we have got epicyclic gear train. Okay, so what is the how to distinguish this epicyclic gear train? So if you look at this particular figure, so you can see suppose gear 1, gear 2. Okay, and it is being connected by a certain arm. Okay, now the basic distinguishing character is, so here the axis of the gear wheels they rotate about the axis of other wheels in addition to revolution around their respective axis. Okay, that means it has got two different kind of motion. One is, if you just consider, suppose this is gear 1, this is gear 2, okay, and this is the arm, which is pivoted pivoted. They are connecting, this arm is connecting both gear 1 and gear 2 and pivoted at the center itself. Okay, and gear 1 and gear 2, they are in mesh. Okay, so now what will happen, if you just consider gear 1 and gear 2, then they are kind of external mesh. Okay, and gear 1 is rotating in the anti-clockwise direction, so gear 2 will rotate in the clockwise direction, so this can be one movement about this axis. Apart from that, if you consider, if you give motion to this particular arm, then apart from this gear 2, which is the output one, which apart from having motion about this axis, on axis, it also will rotate around this particular gear. Okay, so now that is, you can see here the axis of the gear wheels rotate about the axis of other wheel, in addition to revolution around their respective two directions. Okay, so we are saying, like, in this particular figure, if gear 1 is fixed, this is a gear 1. Okay, and arm B is rotated about this, okay, O1 position, then gear 2, it is bound to rotate upon as well as around one. Okay, so that is the two different motion you can see. And if we think of, like, fixing the arm, if the arm is fixed, this arm, okay, arm B, which is connected, then both the gears will be fixed automatically. That means they will become, this epicyclic gear train will become simple gear train. And what is the usefulness of this? The usefulness of, like, for high velocity ratio transmission, it's very useful. Okay, and similarly, mostly you can see it is used in differential gears of automobile, also in the brake gears of lathe, also different mechanical wristwatch, etc. You'll see epicyclic gear. Okay, so next, one particular example or extension of this epicyclic gear only. Okay, that is nothing but we also call it a sun and planet gear. So it is nothing but kind of extension of your epicyclic gear train. And why we generally call this sun and planet gear? Because the motion of the gear wheels, they actually resembles the normal motion of a planet around the sun. So this, what basically happens, if we consider the sun in the solar system, it is at the center, right? And different gears, okay, not gears, sorry, different planets, okay, they have their motion about their own axis as well as they move around the sun. Okay, so similar kind of motion we can, it is generally exhibited in the sun and planet type of gear. So if you just extend, and if we put a particular ring gear having internal teeth, okay, or we also call as annular wheel. Okay, when we add an annular wheel to the epicyclic gear train, then this particular combination is, we call it a sun and planet gear. Okay, so now here, as you can very easily see, so this is the center gear, is nothing but we call it start gear, and this gears, which actually the slave gears, or they move around about this axis as well as move around this particular sun gear, is known as the planet gear. Okay, so now this particular ring gear, or the annular wheel, it has got internal teeth cut here. So this and these 3 and 4, gear 3 and 4, will be internally meshed, and gear 1 and 3, they're external. So here, this particular example, in different, for getting high velocity ratio, similarly in different mechanical clocks, etc., ratios, etc., you see. Okay, now how to analyze this. So in the next class, we'll be solving some problems related to gear train. But prior to that, just let's see how we can analyze the motion of epicyclic gear train. Okay, so for doing that, actually, what we do, will be considering different conditions of motion. Like, we'll consider as if the arm is fixed. Okay, arm is fixed, and we are giving certain motion to, suppose, one element. So we'll try to see what are the motion that we'll get in the all the different elements. Okay, so condition of motion will have one particular condition of motion. So for that particular condition, how the other elements, like the arm, the different gear wheels which are there. Okay, so it is not like only two or three kind of gears only will be there. Okay, sometimes depending on, like, the application, we may have multiple gears. There will be different gears. Okay, so that means it will have multiple elements. So we'll see and try to analyze each and every like element. We'll try to see, suppose how what is happening if a particular type of motion we are giving to. Suppose let's consider just like this case. In this particular column we'll see we are first considering arm is fixed. Okay, and one wheel is we are rotating through one revolution in the anti-clockwise direction. This plus one means we are considering anti-clockwise direction motion to be positive. That means automatically all those clockwise motions we need to consider as negative. Okay, so then we will see, suppose if this is arm is fixed, what is the motion of the element? Arm motion is zero because it is fixed. So gear wheel, already we have said that gear one we have given plus one revolution, that is plus one, and because of that what is happening to gear two we'll try to see. Okay, if this particular motion we are giving, so 1 and 2 are externally meshed. So if this is rotating in anti-clockwise direction, 2 will rotate in the clockwise direction. That means the directional sense has sensed. That means negative sign need to be considered, and we are considering negative sign. And in terms of the number of teeth, that is T1 by T2. That is how after one after another we'll try to analyze it, and finally whatever the conditions that is there, okay, we'll try to tackle those conditions and find out suppose what are the number of teeth etc that will be required for a particular place. Once we solve problems, in this particular table will be easy for it. Okay. Similarly, you can have like you can see like what are the different torques that is there in the epicyclic gear train. So as you can see, gears in epicyclic gear trains, they are moving with uniform speed. So that means uniform speed means no angular acceleration. So if that is happening, then this gear train is in equilibrium under the influence of three external torques. See, they are rotating, but but still there is no kind of, you can say, equilibrium is maintained. And for maintaining that equilibrium, basically three external torques are there. One is the driving torque or the input torque that is working there. One is the driven output torque, okay, for the driven element, that is T2, and another is this all these torques, okay, whatever be the imbalance there. So there is a fixing or holding torque that is also acting, that is T3. Now these three out in the under the influence of all these three torque, still it is in equilibrium. So that means for equilibrium condition we can write T1 plus T2 plus T3 equal to 0. So T is nothing but F into R. So like the external process F1, F2, F3 will consider, and the corresponding radii, okay, that is R1, R2 and R3 corresponding values we will consider. Okay, so that means we can write F1 R1 plus F2 R2 plus F3 RT equal to 0. Okay, so the energy of the train is zero if all losses due to friction etc. are neglected. That means from there we can extend it to in terms of the uh, torque and the your angular velocity. Okay, that is T1 omega 1 plus T2 omega 2 plus T3 omega 3 equal to 0. These are nothing but the angular velocity of driving, driven, and the fixed element. Three elements are there, not one, two, three. Okay. So for fixed element, if we say it's just fixed, automatically the angular velocity becomes 0. That is omega 3 is automatically 0. So these are basically these three influencing torques are there, under the influence of which it is still in equilibrium. That means T1 plus T2 plus T3 has to be 0. Okay. So basically with this we have come to the conclusion of the theory part for this particular module. So in the next class we'll be solving some problems related to see some numericals related to gear train also. Okay. So if you have any question you can ask. Otherwise we'll be like stopping here. So is that okay? So we'll stop here then. So respond to your name calls. Nilutpal. Nilutpal. Absent. Shankar. Shankar. Absent. Arsishman.
Present, sir.
Rehan.
Present, sir.
Partha. Rishikesh Basumatari.
Present, sir.
Hermiki. Absent. Mahosal.
Present, sir.
Teja.
Present, sir.
Rishikesh Nath.
Yes, sir.
And Emil.
Yes, sir.
Okay, so thank you everyone for joining. We'll meet in the next one.
Thank you, sir.
Thank you, sir.